Hi again, everybody. Welcome back to our statistics class notes. We're in section 9.3 where we're learning about constructing confidence intervals for a population mean. And we're on page 146, and we're going to go through example 164 here. So finding a confidence interval for a population mean using StatCrunch. So data on the speed in miles per hour for a random sample of 30 cars traveling on a highway was collected. The mean speed was 63.3 miles per hour. That's our sample speed, that's x bar, with a standard deviation of 5.23 miles per hour. So that's our sample standard deviation, so that's S. All right, so A, find the 95% confidence interval for the mean speed of all cars traveling on the highway. First, verify that the necessary conditions hold in order to be able to accurately construct this interval. So that means to verify the conditions of the central limit theorem for means. So 1, the sample is random and we're going to go ahead and assume independent. 2, the sample is large since the sample size is 30 and it has to be at least 25, so that's certainly greater than or equal to 25. And 3, the population is big since it is reasonable to assume that there are at least 10 times n, the sample size, so 10 times 30, which is 300. There's at least 300 cars traveling on the highway. Okay, so now we're going to use StatCrunch. So we're going to follow the drop-down menus, and I'll show you in just a second. You go for Stat, T-Stats, one sample with summary. And you input the following. You input the sample mean of 63.3, the sample standard deviation of 5.23, the sample size of 30, and you click on the confidence interval for mu, changing the level to 0.95. So this is the picture I've taken of what the menu looks like. So let's go to StatCrunch. I'm going to go to Stat, T-Stats, one sample with summary, because I only have the summary, not the actual data. So the sample mean, remember, is 63.3. The sample standard deviation was, I forgot already, 5.23. 5.23. Sample size was 30. Means we will have 29, right? N minus 1, that's n, degrees of freedom. And we're constructing a confidence interval right now. Hypothesis test will be for section 9.4. Confidence interval for mu at a level of 95 because we wanted 95%. That's good. I hit compute. Here's my results, and these are also cut and pasted into your notes. So we can see that the left side of the confidence interval, the lower limit is about 61.35. The upper limit is about 65.25. So we are 95% confident that the true population mean, the true average of all the cars traveling on the highway, is somewhere between 61.35 miles per hour and 65.25 miles per hour. So let's go back. So there's the results that I just showed you. Here's me writing it out in interval notation. And I rounded it to 2 decimals like I was speaking about when I was showing you on StatCrunch. And I just want to make a note here that T-star does not show up directly in the results. So, however, if we were really interested in finding it, we could use our knowledge of the width of the confidence interval, which we know is 2 margins of error. So we know that 2m, right, is the width of the entire confidence interval, so 65 and I used all the decimals here because I wanted to see what T-star was to as accurate as I could. So I used 65.252914. That was if I looked at all the decimals StatCrunch gave me, minus the left side, 61.347086. So 2 margins of error is this 3.91 rounding. And that means the margin of error is that value divided by 2, which is 1.95 if I were rounding it. Now the margin of error is T-star times the standard error estimate. So if I divide both sides of this simple equation by the standard error estimate, then T-star is the margin of error divided by the standard error estimate. So there's our margin of error divided by the standard error estimate, and I can see what T-star is. Now again, that's not something I would ever have you know off the top of your head, but if you ever needed to find T-star, this is how you could do it.